Welcome once again to your weekly dose of all things Lawo at the Lawo Lounge. Grab a coffee, sit back and relax and enjoy the next 45 minutes of tech talk interspersed with a dash of fun. This week we are in focus with our media infrastructure team who are going to show us the important aspects to flexibly and reliably conduct your infrastructure. Also coming up, we visit Bogota, Colombia as we go on the road to another one of our recent IP installations. And we also talk with another important Lawo colleague in Meet the Team. But first, the answer to last week's 50-year quiz question. What is the name of our super audio node which is used with our Ruby mixing console series? The correct answer, of course, was B, Power Core. We will be sending some of our Lawo giveaways to the winners shortly. But stay tuned till the end of the show for your next chance to win on our 50 years quiz. Now, let's get started. Now, as South America has a strong part to play in our show today, I decided to use this theme to choose my next victim to interview in our Meet the Team series. This week, it's the turn of Samantha Brown, our Head of Audio Production Solutions. So, hi Samantha.
Hi Jamie.
Or can I call you Sammy as everybody does?
Yes, of course.
Okay, perfect. So, we heard last week from Dominic Lipfin about his family connection to the company. And you also have some additional ties to the company, don't you? So, tell us your background to your Lawo story.
Yes, I joined Lawo in 2014 as the South American market requires some more resources. Me being Chilean, I was based in Chile to be able to do commissionings, on-site commissionings and trainings. Well, as always, onboarding it is needed. So I was given trainings here in Germany, and one of those was regarding our radio product line. The trainer was one of the radio configuration engineers. At the end of the day, the training was so good and the trainer was so smart and fun that we got married.
Wow, that's what I call a high quality training.
That's the best one you can get.
Now, you are part of our SSE team which supports both pre-sales and project deployment globally. So tell me, for you, which is more fun, the pre-sales or the project deployment?
Okay, that's a tough one. I will go with the project deployment. It gives you the chance to be during all the phases in the real happening. Also, you can work with the customer as a team, and the most rewarding part is at the end where you can see the on-air phase or the shadow mode, and you see happy customers, enhanced workflows, our products all combined into one system. And this is what makes us happy, and this is what makes our day.
Yeah, cool. Now, Sammy, just a little bit of fun with you. I've got a quick fire question round for you so that we can get to know you better, okay?
Perfect.
So are you ready?
Yep.
Okay, here we go. Snow or sand?
Sand.
Morning or night?
Night.
Are you music or sport?
Music.
Now I think I know the answer to the next one. Hot or cold?
Hot.
Okay, Mac or PC?
PC.
Sweet or sour?
Sweet.
Here's another good one for you. Samba or tango?
Samba.
Okay, sneakers or flip-flops?
Sneakers.
Okay, and the last one. Audio or video?
Definitely audio.
Yeah, okay. There's a reason you're the head of our audio solutions department, right? Okay, Sammy, thanks for talking to us today. You take care of yourself. We'll see you soon. Okay, bye.
Thank you. Bye-bye.
Bye. As modern media IP infrastructures are now based on network switch technology, the control and orchestration of signals becomes a key element of the solution. Topics such as stream routing, redundancy, system resilience and patching are all key elements which need careful understanding and implementation. Add to this the expectation of users to control the infrastructure using tools and methods that are familiar. Understanding how to conduct your infrastructure is as important as the hardware technology you choose. Stefan Turke and our media infrastructure team are here to discuss these elements and more as we put the importance of network control in focus.
Well, thank you, Jamie. And I'd like to welcome Jürgen Konrad. He is the Senior Solution Architect at Plaza Media, and he's coming to us from, I would hope, which is the Plaza Media Lounge, to talk a bit about his system and his experience around the IP technology. So, Jürgen, welcome to the Lawo Lounge.
Hello. I'd love to say that this is the official office, but no, this is just the system administration think tank. So welcome as well from my end.
Great. So what I'm curious about is you and the Plaza Media are running and operating a full IP system end-to-end in daily operation. And I would be curious, what's the experience like now that you have gone through all the process and have it up on the air and operated?
Well, I can tell you there's no such thing like a daily routine, but this is less related to the technology itself. It's more related to all the drivers and the thinking why we wanted to go into IP in terms of scalability, in terms of UHD. I can tell you that since 2018, since the system is running, we are growing constantly. So we are right in the middle of a constant migration and expansion phase. So that is why the technology itself for the operators is not really visible. So for them, now all of a sudden everything can connect to everything. So this helps them for their operation. And as we also made various changes on the workflow side, so they have a smooth and seamless front end where they can now interact and combine all the different assets and sources that they need.
That's great. So now that we are in these very special times for all of us, and while I think this has not been like a major design scenario for your system, I'd be curious, the way you build your system, does it provide you with either foreseen or unforeseen upsides to navigate the situation around COVID-19?
Well, what was quite surprising for us, I mean, like for everybody, people were all of a sudden banned from production. So nobody was supposed to do production, to stay in the same room with other people. And of course, we needed to find a way to quickly come back to production. And this is where a very strategic decision that we made for this large system definitely has paid off. We call it workspace virtualization, which means that we haven't built rooms for a specific task like graphics or EVS room. We build rooms for generic purposes, and we can allocate the different tasks to pretty much every workspace. So this is imagine like a login procedure, so that the operator chooses the customer, the production, and then who he is, like the EVS operator. At the moment where this is happening, all the logic in the backend make sure that he sees the right signal, that he has access to the right device, and so on. So this allowed us that productions that were typically done in one room where people were sitting next to each other, that we were able to split this production into just one person per room. So they just needed to enter a different location, log in into the same production, and then they were interconnected. So this is where all of a sudden things were now helping us to come back on track without thinking about this specific aspect in the beginning, but this definitely helped us. And the second aspect is that in times of IP, where everybody was sort of sitting at home, this hit us right in the middle of an expansion phase. So we also needed to find a way how we could do all the commissioning, all the configuration in the meantime. And that is actually what I'm doing right now. You see on my laptop, I have a remote camera. So I can now directly look into a production control room, which is currently set up. You see, this is a live camera. I can remote control it. And this even allowed me to do all the multi-viewer layouts and check if all the label transfer and so on is working. I love IP.
Wonderful. So now that you are so inside this technology and you've been through that process, as a system designer, is there anything you would advise people who are in the beginning of this process that you have been 2 years ago? What to think about, what to put front and center to make this a successful experience?
I think everybody will be at the position to decide whether the new technology and IP technology is ready or not, or if maybe SDI is the better option. So this is where I think it doesn't make sense to compare these two technologies because they're pretty much different. But what is so important is that you look at the outcomes of what you want to achieve. And this is what we did. We did not, the driver for the project or for the new broadcast sender was not the technology. The driver was the customer needs and the content. So we started the whole thing from the content being the middle part of the whole project. So which then means we needed to look, where's the content coming from? What are we doing with the content? And what are the necessary tools like rooms, like control elements and so on, and where is the content supposed to go? So with this content sitting there in the middle, it actually was a guiding light. So this was showing that everything sort of needs to be connected, and we need to think about from very small productions to even large-scale UHD productions. And this is much more efficient to achieve with IP, because that is something where you can grow into different parts of the building without bottlenecks. You can have a decentralized IP backbone, which allows you to now add the studios of what we did. So we're just in the middle of connecting all the studios now to this IP backbone. So this is a step-by-step procedure. You've just seen one, which is currently about to be set up. So the outcome has to be clear. So if you just see this from the technology point of view, I think you don't see the full picture of IP.
Well, this is a perfect summary of the way we also see the technology and the prospect. And I would like to thank you for your insights and looking forward to learn more in the future in this format.
All right. Maybe next time, then from the real location and not from this think tank area.
We like your think tank.
All right. I like it too.
Bye.
Bye.
Here with me is Axel Kern, Senior Product Manager, Control and Orchestration at Lawo. And he's in the office in Wiesbaden. And the two of us would like to guide you a bit through the various forms of orchestration, or so to speak, the things we can conduct from a control system perspective when it comes to IP infrastructures. And Axel, maybe we start this from the basics. So we know orchestration is a hot topic in the industry. It's a lot talked about. But if you think of it from the control system perspective, what is probably the most basic form of orchestration you can think of? And let's start there.
Yeah, good point. It's always good to start with the basics. So I have a working example here, which is potentially good enough to explain very well what the topic is all about. But I would prefer to start with a little theory up front. And I would like to share my screen in order to show what I mean. So you see a simple little drawing over here, which shows the main components of basic infrastructure control in an IP infrastructure. We have a VSM system, and the VSM system literally sees two components to talk to. First is the transmitting device. We see this usually through the device's IP address. We know how to talk to the device, and we get essence data information from the device, literally the SDP description of the data or the multicast address as such. On the receiving side, we also see devices either directly or through our gadget server gateway, which is a driver proxy more or less. And through this connection, we can see what edge device on the receiving side is consuming or what kind of mechanisms it basically wants to see in order to receive a stream. So we have the transmitting side and we have the receiving side. And that is literally it. There's a network in the middle which connects the edge devices to each other, and which is literally the backplane for the essence data exchange. but we do not control anything of that network. We rather rely on standard IT mechanisms, which are IGMP in that case, in order to establish a flow from transmitter to receiver. There's a lot of proprietary mechanisms in there. Devices from specific manufacturers require proprietary control, or they follow NMOS specifications, both possible.
So in this scenario, if an operator sits in front of a VSM panel and he wants to create a new connection between the transmission and the receiving device, what is actually happening in the background?
A straightforward command set is happening. So we have the information about the receiving essence data, the descended essence data. We know the multicast address or the SCP information of a stream. We store it, connect it to a signal path, which is necessary in order to create cross-point control items on graphical panels, so to say. And as soon as the operator clicks on or presses a physical key on a rec panel, we initiate this command and translate it into the receiving side. The receiving device is getting the information of the flow it needs to switch to, initiates a join into a multicast group, and gets the flow from the network, literally. So here's an example how this feels in real life. I have a panel here, which is literally showing the simple control. We have a monitor in front of me, being the VR receiver 1. We have a simple setup which just allows me to stream 2 different streams, and we have the 2 streams on source keys. And if I press on one of those keys, I see the content on my screen in front of me changing. This is the simple switching approach.
So you basically tell the receiving device to look for a certain stream, and then you leave it to the edge device and the network to instigate that connection.
That is correct. Although we talk to the edge device and we get a response on our triggered command from the edge device, what we do not get is any response from the network.
Okay, and under these conditions, I mean, the network, I guess, needs to be big enough to not run into conflicts.
This is correct. This mechanism we see here is literally a working mechanism on monolithic setups with a single switch in there, where you usually have no issues with bandwidth limitations, where you have no blocking situation in any way, in any meaning. It is feasible and suitable for mid-size installs with monolithic setups. Absolutely, yes.
So, what happens, or what would you propose if you had a larger network install, probably with a set of switches that are interlinked? How would this be addressed then?
Yeah, let's jump into the next example, which is looking at exactly this point. If I take the general situation with edge devices on both sides and a network in the middle, then the overarching issue with IP infrastructures is that the edge devices and the network as such are the new backbone for essence data exchange, but none of those devices knows what the other devices do. So there's no overarching instance at the moment other than the control system, which knows the overall status of flows. So we have no consistent understanding, no transparent understanding of the entire routing in the network. And this leads us to the fact that if we just talk to edge devices and something happens in the middle with the network, for example, we don't get any information about that. And being a control system on top without having the information of any issues in the controlled infrastructure is not what we want. So we have to have a clear understanding of the infrastructure status. We also have to have a clear control possibility of the network underneath in order to tell northbound to the operator a consistent status, to provide the operator a consistent status of whatever he does.
And does this mean, so to me, it's like transforming the network from what was just a black box, you had no visibility, into actually having visibility. Does this in practice mean you talk to all the individual switches in the network one by one?
This would theoretically be exactly the way to go forward, although we like to work in a more summarized way. So what we do in this case, and this is literally related to the fact that the network can be of any size. In this example, we just see 3 switches, 2 leaves, 1 spine. But in recent projects which we do, we see networks in sizes of up to 250 plus switches. So what we prefer is some kind of abstraction layer between the physical switches and their status northbound. And this is usually provided by an SDN layer. We communicate to the edge devices still on the receiving and the transmitting side, and we communicate to the in the middle positioned SDN, which is abstracting the communication into the switches. And this gives us all feedbacks, all responses of any component in the network which we need to create the required transparency. And you hear me right. It is no longer a single command which we send out. It is no longer a single command which we send to the receiving side and establish a full flow. We still do that, but we add another command alongside with this. We send a command to the SDN here and let the SDN create a flow from an ingress to an egress port. So the 2 commands which we've now sent are basically creating the 2 responses, and the 2 responses in summary give us the transparency we need. And I think I must be complete here. We are currently talking to 2 switch manufacturers, to Arista and to Cisco, and the mechanics they offer in order to be controlled are slightly different. No matter of the different mechanisms which are basically incorporated here, we get a clear flow status back of either manufacturer. And this is actually what we want. It is not about the mechanics underneath. It is about the status we want to have back in order to create this overarching consistency of flows.
Okay, I get it. So now you have visibility on all parts of the network. You can see the chain. So if we go back to, or compare it to the example we had before, an operator wants to install a connection on the receiving side. What is actually happening along the way until this is all properly working? Can you take us through this process?
Yes. Just the last word on the theory in order to answer your question. We send 2 commands. As I said, we send a command to the receiving side, which contains the SDP or the multicast natively. The edge device is basically triggering a command towards the network. And at the same time, where we send the command to the receiving side, we send a command to the SDN and allow the SDN to stitch this flow from the ingress to the egress port. Now let's look into the real example which I'm sitting in front of. And in order to understand this, I give you a bit of a clear overview of what you will see here. So we have on the transmitting side a V-matrix system with a couple of C100s, and there are 2 streams are basically created by the system. One which is showing a bit of a cloudy sky, and the other one is a artificial fluid coloring here, which you see. And I have both streams in the network, and the network basically consists of 2 leaf switches and a spine switch in the middle. And on the receiving side, I have a simple single U V remote, which is connected to a monitor right in front of me. I have a VSM system controlling this setup, and we basically have the target, the destination key simulating my monitor and the 2 sources underneath. This is what we basically see. So in my example over here, I have this panel, And what I also want to recall is the matrix, the literal representation of my ins and outs of the network. What I also have is a flow representation from the network. It is the active flows, the is state of the network, which is in this example rather simple because I have a limited setup. And it shows me the current streams. So at the moment, if you look at the screen, you see the cloudy sky. And if I select the second source to the screen, then another source is routed to my stream. What happens in the network flow representation is with every stream I create, or with every new cross point I trigger, I will, as I talk to the same destination, I have to eliminate an existing flow and join a new flow, literally. So, and this is triggered by the key press over here, and the table over here shows me these two actions. So you will see a red line indicating this existing flow going to be deleted, and you will see a green line, which is temporarily green, showing the new created flow. Take a look. And I switch back to the artificial fluid, back to the sky view. So what you see here is the things which happen in the network while I'm switching to a new flow. And it is giving me all the data which I'm expecting to get. I see the source signal name, so the device which is sending me the streams which I got sent, the multicast addresses to these streams. And I also see, and this is very important, the source interface. So this is the ingress port into the network, Ethernet 4. This is where the C100 device is literally hooked on. And what I see here is the active flow is exiting the network on the egress port on the second spot, on the leaf 2, on the second leaf, literally on Ethernet port 1. If I switch back, this is going to change.
So this basically means you talk to various parts in the chain and have active feedback and information if this is all working out properly. What happens in a scenario if one of these devices along the chain doesn't react as wanted? For example, is not available.
Yeah, that's a very good example, and this can always happen. As I said before, there is no overarching intelligence or controller available which knows the status of all devices other than VSM. Previously, in the baseband world, we had a controller card which knew a lot about the controlled modules in a crate, but that is gone, that is history. Now I have basically plain devices directly hooked to the network. They don't know the status of other devices, and we have to make sure that VSM knows all the status and creates a comprehensive and consistent response towards the user. So the user presses a key and assumes that there's a direct reaction. Now, if one of the devices which is involved in the current trigger, the current command, is off the network, and I simulate this by switching the receiving side on this end off, I deactivate it. If I now switch the source, and I said before that I create two commands, one into the network infrastructure, the other to the edge device. You see the edge device not reacting, but you see the infrastructure still reacting. I have not done anything with the infrastructure. It is still up and running and responsive. So commands will be shown and create responses indicated in the network flow window. If I switch back to video 1, I see the corresponding flow stitched. But what I don't get is a response from the receiving device, and I get this indicated in the master matrix, the master view of my signals here. You see an equal sign over here telling me that the previous status of the receiving side, of the receiving device, is still valid or assumed to be valid. But so there's not been any response from the device. It tells me we keep the status from the last response, which is looking at video 2 still. That is not right, because the last command which I sent into the network was the connection to video 1. And this is basically also indicated on the panel towards the user. I have a partial response. I have the network responding to me, but it's not a full response, and this is why this cross point is indicated in orange. Orange cross points in this state means a partial response and the representation of the internal cross point status of VSM. So the functionality flow state master is basically active here, telling me that the internal cross-point status of the matrix should be this connection, but there's one device in the chain of the signal which has not reacted. And we also store the commands. So as soon as this device, which is currently not active or not responding, comes back to the network, comes back to the infrastructure, we throw this command back at the device and make sure that it is involved in the flow and that the flow is going to be reestablished completely. So let me reactivate this device again and have a look at the cross point over here and to the screen in front of me. So now the orange status has been replaced by the blue status, which is a full valid cross point by the device being back. I also see the stream ending up at my destination.
Okay, so that means that that if the device is not available, then you still can execute the connection as soon as it comes back.
We execute the connection, and we also store the whole command. As soon as the device comes back, we play out the buffer and make sure that the cross point is completely executed.
And I assume there's the range of reasons why the device is not available.
Yes, it could be the device which is inactive due to a service maintenance or whatever power outage. But it could also be that you are acting on a studio floor, and that is the example which I also wanted to show you. You might be in a situation where you model your studio layout, and you have to move a device from one corner to the other. A stage box has to be reconnected because you moved the tribune, or you have to connect a teleprompter to a different wall box. And the feature wall boxing is taking care of this. And this could look like a simple reconnection. You see the right purple line here, which is simply indicating that a device is reconnected into the infrastructure at a different switch port. What you do not want is, as soon as you route a flow to a device, which the blue sky on the screen in front of me is just showing, you move the device to a different port, but you do not want to reroute manually this essence data to the device. It has already been prepared, so the system should automatically take care of to reroute the flow accordingly to the new position. And I can simulate this in the example in front of me. I don't do any interaction with the infrastructure here. I don't activate any cross point on the device. But what I do know here is you see the device, which is the receiving edge on the network. And you basically have two prolongations of network ports. I have port number 1 and port number 5 prolonged to this device by fiber cables. And I now disconnect the fiber cable number 1, which is simulating the port number 1. And I have the fiber cable number 2, which is simulating port number 5, and I connect it. And this is how I simulate the moving of a device to a different port. And what you see in front of me is after I have connected the device to a different port, the stream is rerouted. So that is very, very necessary in order to make sure that there's no manual interaction required.
And is this limited to another port on the same switch?
This is not limited to a same switch functionality. This is basically acting across the entire switch infrastructure.
Wow,
so we identify the device by an ID and make sure that as soon as this ID returns to the network at any position, we can reroute the stream accordingly.
Okay, so this means basically once the device knows what it's supposed to connect to and you do not change this actively from a user perspective, this travels with the device wherever you plug it.
Very true. This is exactly it.
This is very powerful. So to wrap this up, there's two ways you can control your infrastructure. If you have a monolithic and non-blocking provision network infrastructure, you can work with basic control and have the broadcast control system just talk to the end nodes. And once the broadcast control system has told the end nodes how to connect, the end nodes will figure that out with the network infrastructure, which is the process is not visible to the broadcast control system. In comparison, the advanced control utilizes an SDN layer, which allows the broadcast control system to also have a look in and management inside the network infrastructure and can instigate and also visualize the entire signal chain and take care that what the user wants to switch is also actually realized. Both architectures are perfectly fine to choose. They are situational and come basically down to system scale.
Did you know SmartScope supports SMPTE 2110 logical group monitoring? Lawo offers two products to help engineers monitor IP broadcast infrastructure. SmartDash answers the question, what's happening on the network? And SmartScope answers the question, what's happening on the wire? Taking a closer look at SmartScope, an engineer can monitor and analyse a variety of IP audio and video standards with a significant amount of information available to them. Packet pacing information is particularly useful for monitoring constant bitrate flows such as SMPTE 2110. The 2110 standard separates the audio, video and metadata information into individually synchronized multicast data streams. This makes it a flexible, bandwidth-efficient standard for the real-time transfer of broadcast media signals. 2110 flows usually require separate monitoring of audio and video streams. SmartScope, however, allows an engineer to combine audio and video multicasts into a convenient logical group for monitoring. If you want to set this up in SmartScope, choose MSL from the main menu. Then click the hamburger menu in the bottom right-hand corner. Then click the spanner icon. You can now give your group a description and an alias. Next, select the video and audio flows to assign to the group. Click Create. Subscribe to the 2110 group. Next, choose Overview from the main menu and click the 2110 group to begin monitoring. So now you know, SmartScope supports SMPTE 2110 logical group monitoring. Thanks for watching and see you next time.
So, you have just been given an insight into wallboxing and Flow State Master, two new features of VSM Studio, which are going to be introduced to the market in Q3 2020. I would like to take the opportunity to introduce you also to another feature in VSM Gadget Server. The NMOS ISO 5 driver in Gadget Server brings us immediate compatibility with all compatible third-party devices for the purpose of stream routing, aka connection management. This driver will be available soon, so stay tuned for updates. And last but not least, I would like to introduce all those of you who are interested in more details about panel inheritance, our latest improvement of the panel creation process in VSM Studio, to a how-to session which has just recently been recorded by Steve Barnes, who in a very comprehensive way explains you about everything which has been introduced with panel inheritance from A to Z. You find a link in the chat. Enjoy.
This week, we're going on the road to Bogota, Colombia to visit one of our most recent 2110 media infrastructure installations. RCN and Wind Sports installed our full complement of audio, video, control and monitoring solutions to power their facility to the next generation. As one of the premier sports channels in Latin America, take a look at how Lawo helped RCN make this leap in technology shift to create a brand new cutting-edge broadcast facility.
We only knew what we read on a piece of paper. We didn't know whether and how IP worked in real life. Today, I can confirm that it does an excellent job. This new IP technology not only meets our expectations, it even manages to exceed them.
Why not IP? This technology offers financial benefits and will allow us to produce high-quality content for many years to come.
We know it is easy to implement and to deploy. That is how it should be with any new technology we adopt. I have to say that Lawo helped us enormously during our transition. Their solutions are extremely versatile and have multicast signal distribution built right in. The ability to transmit signals to all required destinations and to quickly access them for monitoring and processing purposes allows us to prepare cutting-edge productions.
Our workflow has changed quite a bit. We're highly satisfied with this groundbreaking technology. It allows us to provide the best viewing experience in this part of the world. Both the production department and our various operators quickly felt at home with this new technology.
WinTV is a channel that has always been at the forefront of important new developments. With the deployment of its ST2110 infrastructure, we are sure that it will establish itself as one of the premier sports channels in Latin America.
We are planning to upgrade the remainder of our infrastructure to ST2110 compliant solution. Similar to what we have done at WinMass, RCN, its parent company, will soon upgrade other content types, such as news, feature and other sports productions to IP ST2110.
One of the most important aspects for the implementation of any IP infrastructure is that it needs to be both ST2110 and ST2022-7 compliant. For us engineers, guarding against signal loss and dropouts by means of a redundancy strategy is paramount.
Our infrastructure is a hybrid system and highly versatile. Lawo's vMatrix allows us to access and share all our production resources. There were some fears that applying what we had in mind would be complex in the IP domain. vMatrix quickly dispelled them all and showed us the unprecedented flexibility that IP affords. The most important aspects about the multi-viewer solution provided through vMatrix are the speed at which signals can be accessed and switched, and the convenient access we have to all signals on the network. For our workflow, we use one vMatrix as gateway for signal conversions from SDI to IP, as well as from IP back to SDI. This allows us to share signals with another building that is about 500 meters further down the road. VSM is an extremely useful control tool with a highly intuitive user interface.
RCN uses the VSM system for everything to do with orchestrating the devices connected to our IP network. It provides flexible control over our audio and video signals as well as metadata. And it makes our operators' lives much easier. In addition, its hardware and software panels are highly intuitive. We also configure our multi-viewer system with Lawo's convenient The Wall software.
We use an AES67 connection to our mixing console. Basically, this is a highly versatile system that allows us to use all audio streams anywhere on our system. We chose a Lawo MC236 mixing console and an A-Stage stage box, which is stationed in the studio and used to route the signals of our analog input sources to where they're needed. This audio integration with our IP system happens via AES67. We use our infrastructure not just for sports events, but also for newscasts and feature productions. For this, we need a flexible system capable of providing access to all audio signals.
I'm convinced that all our tools contribute to a cutting-edge master control room, a better studio, as well as better analysis and production options, and that this will help us become Latin America's premier sports channel.
The integration of our solutions with automation systems and the ability to work with solution providers over the internet are just some of the benefits we can now reap. Implementing this new technology on a massive scale makes a lot of sense.
It's now time for our 50 years quiz and your chance to win some Lawo giveaways. The question this week is about Lawo's award-winning V-Matrix system. What is the maximum possible number of I/O conversions in one of our 3 rack unit V-Matrix frames? Is it A, 64, B, 80, or C, 160? Not so easy, that one. Send your answer and your contact details to lounge@lawo.com for your chance to win. Answer, of course, will be on next week's show. So, unfortunately, we've come to the end of another fun-packed Lawo Lounge. Thanks as always for joining us. Don't forget to register on our website for the next in our How-To series, which is at 2 p.m. Central European Time tomorrow. In the meantime, please take care, stay healthy, and stay connected. See you next week. Goodbye.